So today I will teach you the necessary steps to calculate motor efficiency and how to find a yearly cost savings when upgrading to a more and new efficient motor. So let's say your current motor is 83% efficient. Has a power factor of 85%. It's three-phase. And its volts, it's 415 amps. So we want to figure out the electric input first. The way you do that is using the information provided. You want to do amps times volts square root the phase, so it's a square root of 3 times the power factor, which is 85%, which gives you 8,625 watts. Converted to kilowatts, and you get rounded up to 8.63 kilowatts. Okay, so using the efficiency equation, output over input equals efficiency, we can calculate the output of the motor. So we know the input, 8.63, output's unknown, 83% efficient motor. So just multiply both sides by the input, and that gives us 7.16 kilowatts coming out of the motor, so it's output. Okay, so let's say you want to decide to upgrade this motor to 92 efficient motor. So everything else is the same, besides it's more efficient. It's newer and it's more up to date. So we do know the output. What's going to change is electric input. We know the output, which was 7.16 kilowatts. The new efficiency, 92%. So this is input. The way we can do this is calculate both sides by N, which is input, once again, and divide by the efficiency. And our new electric input with the new and improved motor is significantly different. So let's say you want to see if it's profitable to upgrade this system. Let's say you did data loggers for a certain amount of period and you learned that the system runs for approximately 4,000 hours a year. And the cost of electricity in your area is 11 cents per kilowatt hour. So the old input was 8.63 kilowatts times the hours ran over a year times the cost per kilowatt hour. You can just cross out, and that costs about $3,797.20. Okay? So make sure everything crosses out here. Yep. Okay. So to figure out how much money you will save, you got to do the same thing with the new efficient motor. So we know it's 7.78 kilowatts being put into the motor. It's ran for 4,000 hours. The cost is the same. Your new price, $3,423.20. Simply subtract those two numbers. That's a 7. And you get about $374 saved over a year.